Well, here's one of those that we get to use the first derivative to find out where it's increasing, decreasing, and then the second derivative for concave up and concave down, and then also look for minimums and maximum values. Then it's time to take the derivative. So for that, we'll be using the quotient rule. Take the derivative on the top first, that will be 2x, and then leave x squared plus 4 alone, minus, leave the x squared alone, and now take the derivative of the denominator, which is going to be just 2x. The last part of the quotient rule, the denominator gets squared. And then we should do some algebra. This is going to be 2x cubed. This is going to be minus 2x cubed. So that means those two cancel. And then the only thing left is, when you multiply these two, that's an 8x. So the numerator only has 8x. The denominator is still x squared plus 4 quantities squared. And then, where does the derivative equal 0? That's when the top equals 0. Where's the derivative undefined? That's when the bottom equals 0. So y prime equals 0. That means the top 8x equals 0. Y prime does not exist. That means the bottom, x squared plus 4 squared, equals 0. So for this one, all you need to do is divide both sides by 8, and we get that x equals 0 is a critical value. With this one, you could square root both sides, and then subtract 4, and then it turns out that this is not going to help because this is an imaginary number. Imaginary hashtag. So we don't use imaginary numbers in Math 3A, so that doesn't help, but we do have x equals 0. So then, let's see what's happening. I'm going to try the old-fashioned method, pretending I don't have a graphing calculator. Here's the number line, here's 0, and right there, y prime is equal to 0. Now pick a number on the left, like -1, and substitute it into the derivative. And I only need to know, is the answer going to be positive or negative? So when you take a -1 and square it, that's going to be positive. And when you square it again, that's definitely going to be positive. So the derivative is going to equal a positive on the bottom. And if you substitute a -1 here, it's going to be -8. So it's going to be a negative divided by a positive, which is negative. So that means that the function is decreasing. So it's decreasing on the left side. Then pick a number on the right side, like 1. And when you square 1, that's going to be positive. When you square that, it's going to be positive. When you put a 1 right there, it's going to be 8 times 1. So that means that y prime is equal to a positive divided by a positive, which means that the right side, the derivative is positive. And then that means it's going up. So at x equals 0, that would be a minimum. All right, so I need to do all of this part, this and this and this. So increasing, that's the right side of the graph. So that is from 0 to infinity, but don't include the 0. Decreasing, that's the left side of the graph. So negative infinity to 0. And then there's a minimum when x equals 0, and then to find out the y value, plug in 0 right here to the original function, and then these two will be 0, so it's going to be 0 over 4, which equals 0. Now, I actually do have a graphing calculator, so I can check. So here's the original function. Always graph the original, not the derivative. And then if you look at the graph, let me just change the window a little bit. I don't need the y values that big. You'll see that the left side is decreasing, then it has a minimum, and then the right side is increasing. So these look correct. And if you trace, 0, 0 is the minimum. All right, now it's time for the second derivative. So I need to write down the derivative is equal to 8x over x squared plus 4 quantity squared. And now it's time for the second derivative. So we get to use the quotient rule again. The second derivative will equal, start by taking the derivative on the top, which is 8, and then leave x squared plus 4 squared alone, minus, leave the 8x alone, and now take the derivative of this. So that means that the power 2, you bring it down and multiply. Subtract 1 from the exponent, so now it's raised to a 1 power. And then do the chain rule. The derivative of the inside is a 2x. So there's the top. For the bottom, the quotient rule says you need to square this. Well, if you square something that was already squared, that means it's raised to the 4th power. And then what I would do is notice that this has x squared plus 4. This also has it, and this also has it. So you can cancel one of those from each term. So cancel this completely. Cancel one of these, it will leave 3 of them. And cancel one of these, but it'll still leave 1 of them. So what's left? So if you distribute this 8, there's going to be 8x squared plus 32. This is gone completely, and then this one times that will be 4x, times this is 32, or minus 32 x squared. And then negative 32 and 8. So that's going to leave negative 24x squared plus 32. So then set the top equal to 0 and set the bottom equal to 0. Well, previously I set this one equal to 0 and it was an imaginary number, so I'm not going to fall for that again. But the top, yes, that could equal 0. So then I could subtract 32 from both sides. And then divide both sides by negative 24. And the negatives are going to cancel. Then take the square root of both sides, and there's going to be 2 answers, plus and minus the square root of 32 over 24. So how much is that? The square root of 32 over 24. So x is equal to a positive or negative 1.155. Now, what's happening with the graph? So go back to the graph, trace, and if you plug in 1.155, so basically this little part in here is concave up, and then this is concave down. And if you put the negative 1.155, this part is concave down, the middle is concave up. So for concave up, that's between the negative 1.155 and the positive 1.155. And for concave down, that would be this left side from negative infinity to negative 1.155 union this right side, which goes from positive 1.155 to infinity. Then I just want to go back and look at the problem real quick to see, did I miss anything? Concave up, concave down, increasing, decreasing, minimum, there was no maximum. So, asymptotes. So find any asymptotes. Well, there's no place where the function is undefined, so there are no vertical asymptotes. But what about this? Is this leveling off? It looks like it's leveling off at 1. If I have the window go out farther, like from negative 100 to positive 100, then you can see it's pretty much leveled off at 1. So one last part is the asymptote. So it seems that there is a horizontal asymptote. So if you take the limit as x approaches infinity, and then go back to the original function, which was x squared over x squared plus 4. Because these are both squared, it doesn't really matter if you put positive or negative infinity, because once you square it, it's still going to be positive infinity. So I can do both of these at the same time. Then use L'Hopital's rule. That'll be the limit as x goes to either positive or negative infinity. The derivative on the top is 2x. The derivative on the bottom is 2x. And 2x divided by 2x equals 1. So what I saw in the calculator is actually true. Y equals 1 is the horizontal asymptote.